In this video, I'm going to show you how to solve a typical problem involving the direct compound rule of 3, also known as direct proportionality of magnitudes. However, I should mention that, in reality, the traditional methods don't actually use any kind of geometric proportion or proportion between magnitudes, so it's a misleading title. The traditional methods are based purely on intuition and fall into the problem of arithmetization, because when performing the operations, they don't use the magnitudes. Instead, they remove them from the calculations. And they rely solely on intuition, meaning they teach in a mechanical way which steps to follow to solve each problem, which is incorrect. And that's why none of the traditional methods can be proven for any specific case. However, the method I'm going to teach you is based on the First Algebra of Magnitudes, and it has indeed been proven for any type of problem. It has been approved by the entire scientific community. I'll leave a link in the description to the articles in Spanish and English where the corresponding proofs are provided. But in this video, I'm going to show it to you with a specific case. And it says, 40 boxes with 12 chocolate bars each cost 960 monetary units. How much do 20 boxes with 40 bars each cost? The first thing we need to do is distinguish within this problem which part of the statement contains all the known quantities, where we know everything, and which part is the question where we'll find the unknown. The statement is, 40 boxes with 12 chocolate bars each cost 960 monetary units. Great. Once we've identified the statement, we need to come up with a specific equation. What is this equation? Resources, that is, the units, meaning the measurements which are a resource, and equate them to the work, the measurement that represents the work we want to achieve. So in this case, what is the resource we need? 960 monetary units, which we write like this. And what do we equate it to? In other words, what is the final work that we obtain? Well, we get the 40 boxes along with the 12 chocolate bars that we have for each box. Alright? And here we're going to do what we call a geometric multiplication, or multiplication between magnitudes, according to the First Algebra of Magnitudes. Why? Because here we're working with magnitudes, and they are two magnitudes of different natures. The first magnitude is box, and the second magnitude is bar per box. So since we're dealing with a geometric multiplication, we're going to symbolize it, following the First Algebra of Magnitudes, with an asterisk. Because it's not an arithmetic multiplication, so we can't symbolize it with a dot or an X. Alright? Okay, so now we have the first equation here, that is the proportion that refers to the statement. Now let's find the proportion that refers to the question. What is the question? How much do 20 boxes with 40 bars each cost? Going in order, in the same order as the measurements we've taken from the statement. First we have the cost, and the cost is exactly what they're asking us about. That is, we know what currency we're paying in, which is monetary units. Now then, how many of those monetary units do we need? That's our unknown. In other words, within this measurement of resources, we know the dimensional element, which is the monetary unit, but we don't know the numerical element, which is x. Perfect. Let's continue. How much do 20 boxes cost? That's the next measurement, which in this case is for the work, with 40 chocolate bars per box. This is the second measurement. Another geometric multiplication, and we already have the proportion for the question. What do we need to do from here? If we divide these two equalities we have, term by term, we get a single equality, or a single proportion of quantities for the entire problem. In such a way that if we divide the resources from the statement by the resources from the question, and set that equal to the division of the work from the statement by the work from the question, we get this equality we've been aiming for. But remember that we are working with algebra of magnitudes. That is, we're operating with quantities, not just performing a simple arithmetic division. Therefore, that division we have in this proportion can't be represented with just a single horizontal line. Instead, respecting the primary algebra of quantities, we're going to represent it with two horizontal lines. Now then, what happens? According to the First Algebra of Magnitudes, when a magnitude is divided by itself, it results on the abstract number 1. And here, it turns out that in this proportion, monetary units is divided by monetary units, boxes is divides by boxes, and bars is divided by bars. Therefore, in all three cases, we end up with the abstract number 1. In this way, we now obtain the arithmetic proportion, that is the purely arithmetic operation of 960 over x, which equals 40 times 12 over 20 times 40. We simply need to solve for x, so x equals what? Well, It actually equals 960 times 20 times 40, which is then divided by 40 times 12, which gives 1,600. Returning to the original magnitude, that is monetary units, we have 1,600 monetary units, which is the cost of the 20 boxes with 40 chocolate bars each. And that's it. If you want us to solve any particular problem, leave it in the comments. And what I do ask of you, please, is to help me spread the word about this method, which, as you can see, the solution is always exactly the same for all cases, regardless of whether it's a simple, compound, direct, inverse, or mixed rule of 3. That doesn't matter.